Hi, good day everyone. So today we'll be doing June 2021, number 10. June 2021, number 10. Let's just zoom this in so we could see it properly. Calculate the product of that matrix multiplied by the next matrix. So what we're going to do is write the orders. First thing we're going to do, this is 2 rows multiplied by 2 columns. This is also 2 rows multiplied by 3 columns. We have to make sure that these that you see me put in a box around are the same. They are equal, so they can multiply. And my resultant matrix is going to be 2 rows multiplied by 3 columns. So it will be E1, 1, E1, 2, E1, 3, then E2, 1, E2, 2, E2, 3. Just means this first element is row 1 by column 1. The second element is row 1 by column 2. This third is row 1 by column 3. Same thing, row 2 by column 1, row 2 by 2, row 2 by column 3. All right? So let's do this. Let's multiply. So it's going to be 5 multiplied by 2 plus 4 multiplied by 0. Then the next one is 5 multiplied by 1 plus 4 multiplied by 3. Then 5 multiplied by -4 plus 4 multiplied by 6. Right? Then the next part is going to be -3 multiplied by 2 plus -2 multiplied by 0. Then it's -3 multiplied by 1 plus -2 multiplied by 3. Then -3 multiplied by -4 plus -2 multiplied by 6. Right? So we have the 6 elements. 5 2s are 10 plus 0. Then 5 plus 12. Then -20 plus 24. Then -12 plus 0. Then -3 by 1 is -3 plus -6. Then +12 plus -12. All right. So now we're going to get 10, 17, 20. -20 plus 24 is 4. Hold on. This is 3. Right, -6, sorry. Why did I put 12? 3 2s are 6, not 12. This is -6, then -9, and then 0. And this would be my answer for the two products, right? After a while, guys, with practice, this becomes super easy. So they said, state why the two matrices in A1 are conformable to multiplication. Now, first off, when they say conformable to multiplication, it means it's possible to multiply. And I already went through the reason why by putting these things on top, but they want a worded reason, right? So the number of columns in the first matrix is 2, and the number of rows in the second matrix is 2. Hence they are equal. So hence they are equal in number, hence they are conformable to multiplication. So all you need to make sure, and we did it while we were checking this question, is you need to make sure that your number of columns in your first matrix and your number of rows in your second matrix that you're multiplying are equal, hence they are conformable or is possible to multiply. Okay, this is part B in this question. They said determine the inverse of 5, 4. Is that -3? It is. You're not seeing it, but it's -3 minus 2. First off, we're going to label it A, B, C, D. To find your inverse, I will give you a formula. The inverse is equals to 1 over AD minus BC multiplied by DA is interchanging and minus B and minus C, right? This is the formula you could use. It just means 1 over a determinant of your matrix multiplied by this. What we're doing here is a adjoint. But if you remember this formula, you should be good instead of trying to do the 3 steps, right? So it would be 1 over AD is 5 by minus 2 is minus 10, and DA is 4 by minus 3 is minus 12. Sorry, hold on. Minus 12, right? And then you're going to multiply this by D and A exchanging. So this will be negative 2, 5. You're multiplying B by negative 1. So that's 4 by negative B is minus 4. And C by negative 1, or negative and negative, and a negative is a positive, so it's positive 3, right? So this is 1 over minus 10 plus 12, which would be 1 over 2, by minus 2 minus 4, 3, 5, right? Minus 2 minus 4, 3, and 5. So it's going to be a half by minus 2. So a half by minus 2 minus 4, 3, and 5. A half by minus 2 is minus 1. A half by minus 4 is minus 2. A half by 3 is 3 over 2. And a half by 5 is 5 over 2. You can leave it like this, or you could put the 3 over 2 and 5 over 2 as what you call it, mixed numbers, but this is correct. Okay, so now this one is part C. The diagram below shows triangle OAB, in which OA is vector R and OB is S. Indicate, in addition, E is the midpoint of CD and OA and OC. Where's OC? OC. Hold on. In addition, E is the midpoint of CD. Okay, yes, that is done. Then comma, then OC is equal to 3/4 of OA, and AD is 3/4 of AB. All right. Right. In terms of R and S, in the simplest form, an expression for CD. So they want CD. Where's my pen? Right. They want CD. They want this. So we're going from C to A to D. Right? So this is equal. Let me just zoom in. CD is equals to CA plus AD. Now, first off, they already told us what CA is, right? They told you that OA, right? O to A is R, and then O to C is 3/4 of OA. So this is 3 parts, and this is 1 part. So we want, so CA would be 1 over 4 of OA, right? So CD, let me just write this down, have a little space here. We have CA is equal to a quarter, not a half, a quarter of OA, right? Which is equals to a quarter of, why am I putting a half? A quarter of R, because OA is equal to R. So this is a quarter R, right? And then they want AD. Now, if we look at the diagram again, AD is AD. Oh, AD is OA plus AD. We know that AB is, so first we need to find out AB. Right, so let's look. So AD is equal to OC. Hold on, what am I saying? AD, right. AD is equal to, we're starting with OA. So AD is equal to, they told you it is two-thirds of AB, right? We need to find out AB first. AB is equals to AO plus OB. We know OA is equals to 4, no, sorry, OA is equals to R. So if we want AO, it will be negative R, and OB is equal to S, so plus S here. So AD would be equals to 2/3 will be equals to 2/3 by minus R plus S, right? So we can leave it as this or multiply it out because we have to add. So AD is equals to minus 2/3R plus 2/3S, right? So this is plus negative 2/3R plus 2/3S, right? So it's 1/4 R minus 2/3R plus 2/3S. You can do this in your calculator. A quarter minus 2/3 is actually equal to minus 15 over, not minus 15, sorry, minus 5 over 12R plus 2/3S. So you could rearrange it saying 2/3S minus 5/12R and leave it like, or actually they say simplest form. When they say simplest form, it just, no, you could leave this as is. So this is the simplest form, 2/3S minus 5/12R, and that would be your answer. So let's record this part. This is OE. So they want vector OE. Now, what we would do, let's just zoom in so we could get that bigger. We're going to look at the image. OE would be, let's draw a line to show you what OE would be. It will start from here. Well, not start. It started from actually O. But it's just to draw it. You would connect a line showing OE. All right. Now, OE would be OC plus CE. All right. So let's see. OE is equals to OC plus CE. Now, OC, they already told you OC is equals to 3/4 of OA, which is equals to 3/4 of OA is R, right? And then they said CE is actually equal to 1/2 of CD. Why? They told you that E was the midpoint of CD. So therefore, CE would be 1/2 of, this is 1/2 of CD. Because remember, again, E is the midpoint between C and D. So that's why we have 1/2. Right? So now we already know what is CD. That is from the answer above. So CD, sorry. I already know what is CD. Right? This is equals to 1/2 by open bracket 2/3S minus 5/12R. We got that answer from this part here. Right? Let's multiply 1/2 by 2/3. S 2's will cancel off. That's 1/3S minus 1/2 by 5/12 is equal to 5/24R. So CE is equal to this. And let's add it. So OE would be equals to OC, which is 3/4R, plus, open bracket, 1/3 S minus 5/24R. Right? So this is equals to 3/4R minus 5/24R plus 1/3 S. right? So we're going to subtract these two. As I said, you can use a calculator. I don't see a problem. You just put 3 over 4 minus 5 over 24, and you're going to get 13 over 24r plus, a third s. And that would be your answer, this right here. Okay, so this is part D. They said points O, Q, and R have coordinates. Well, O is 0, 0. Q is 5, 2. R is minus 4, minus 1, 4. Right? So we can see that they have already plotted the points respectively. They said write OR as a column vector. Right? So as a column vector, OR would just be the coordinates of R is minus 1, 4. So let's just write this. So as a column vector, we know R is equal to minus 1, 4. And because it's a column, because it's beginning with O, right, we just take the coordinates of X and Y. So X will be on top, Y would be on the bottom. Right, so it's minus 1, 4 because it's a position vector. If it was a free vector, that's something different, right? But because this is a position vector, you would take your coordinates of R and your X value is on your top, the Y value is at the bottom. Then the last part of the question, I will just write it out because part 2 is they told you to find the magnitude of QR. Now, before we even do that, we need to know what is the column vector of QR. So QR is equals to QO plus OR, right? We know that QO or OQ, let's see what is the coordinates for Q. The coordinates for Q is 5, 2. So if OQ is equal to 5 on top, 2 at the bottom, then QO would be the opposite direction, minus 5 minus 2. So this is minus 5 minus 2 plus OR. What is OR? What we have here, minus 1, 4. And we add these two. Minus 5 minus 1 is minus 6. Minus 2 plus 4 is 2. So we know, wait. Yeah, so we know that QR is this, and we know that the coordinates, the magnitude of QR would be the square root of A squared plus B squared, where A and B, right? So A is your value on top, B is your value at the bottom in a column vector. So it's minus 6 squared plus 2 squared, right? And then you find the square root of that when you add it up. This is equals to 36 plus 4, right? Which is equals to the square root of 40. And you can leave this. This is the square root of 40 units. And this is your magnitude of vector QR. And this is the end of, which year this was? This was the end of May, June 2021.